The hexadecimal program named dragon0 provided in the query is a machine language program for the Apple II, running on a Motorola 6502 microprocessor. This program appears to be related to an Applesoft Basic game from 1982, likely stored on a 5.25 inches diskette. To understand what this program does, I'll analyze the assembly code, focusing on its functionality within the context of an Apple II game, considering the 6502 architecture and the Applesoft Basic environment. Analysis of the hexadecimal code. The provided code is a sequence of 6502 assembly instructions starting at memory address $800. The listing includes opcodes, operands, and their disassembled instructions. The program is likely a small machine language routine called from an Applesoft Basic program, as was common in Apple II games to handle tasks requiring speed or direct hardware access, such as graphics, sound, or sprite manipulation. Below, I'll break down key sections of the code to infer its purpose, noting patterns and significant instructions. Since the program is named dragon0 and is part of a game, it's reasonable to hypothesize it handles a specific game-related function, such as rendering a dragon sprite, animating a game object, or managing a small data structure. Key observations from the code. 1. Memory layout and data patterns. The code spans from $800 to $0 BFF, occupying about 1 kilobyte of memory. There are large sections of repeated bytes, such as $0 BRK instructions $CC $DD $44, and $20, which suggest a mix of executable code and data. In Apple II games, such patterns often represent code, actual 6502 instructions for logic or rendering. Data, graphics data G, sprite bitmaps for the Apple II's higher ease graphics or tables for game logic. The repeated $0 bytes BRK may act as padding, placeholders, or intentional breakpoints for debugging, though BRK $0 on the 6502 triggers an interrupt, which could be used for specific control flow or error handling. Sequences like $CCCCCC or $44 resemble bitmap patterns for higher ease graphics, where specific byte values correspond to pixel patterns on the Apple II's high resolution HGR screen 280x192 pixels, 1-bit color. 2. Key instructions, or $0 FF0 at $800, $882, $986, $0 A09 performs a bitwise ORGAN with memory address $0 F0. This could be manipulating a memory mapped I/O location or a game variable E.G, a status flag or pixel data. Ne branch, if not equal, appears at $820, $822, $896, $898, $8 A6, with branches to nearby addresses E.G, $7 F2, $7 F4. These suggest loops or conditional checks, possibly for animation or collision detection. By compare Y register, instructions like pi number CCCC $82 E, $838, etc. and pi 0 CCC compare the Y register with immediate or memory values. These could be part of a loop indexing through data E.G, sprite or map data. Stast or accumulator, instructions like stan 99, Y $852, $8 before, etc. Store values indirectly using the Y register, likely updating memory for graphics or game state. JSR jump to subroutine, multiple JSR $2020 instructions E.G, $0 A50 and $0 A71, $0 AD2 and $0 F3, $0 B52 and $0 B76 are unusual, as $2020 is not a typical subroutine address and may indicate a data section misidentified as code or a placeholder. However, JSR $87 F0 aft and JSR $90 F0 BFAT suggest jumps to actual subroutines within the program. Graphics-related instructions. Instructions like TSB test and set bits, $846, $8 C7, $97 A, $0 A to B. As arithmetic shift left, $878, $87 C, and TRB test and reset bits, $87 E, $97 C, $0 A7A. Suggest bit manipulation, common in graphics routines for setting or clearing pixels. The repeated $44 and $CC bytes could represent pixel patterns for the Apple II's higher ease graphics, where each byte controls 7 pixels with the high bit determining color group. SBC subtract with carry at $905. SBC 0000 F0X. This could be part of a calculation for sprite positioning or game logic key point G, health, score, or coordinates. JNP jump. Instructions like JNP T9CC $94 E, JNP 4C $0 B1D, and JNP 06310 B7D indicate control flow to other parts of the program, possibly for initialization or different game states. 3. Potential graphics data. Sections like $846 and $851 44 C BB1 B91 99 09 and $96 E and $977 44 C resemble bitmap data for sprites. On the Apple II, higher ease graphics use 7-bit bytes for pixels, and values like $44 binary 01000100 or $CC binary 11,001,100 create specific pixel patterns. The name dragon0 suggests this could be a sprite or animation frame for a dragon character. The data patterns $G, $CC, $44 are consistent with simple sprite shapes, possibly a dragon's body, wings, or head. 4. Context in Applesoft Basic. Applesoft Basic games often use machine language routines for performance-critical tasks, loaded via bloat and called with call 2048, since $800 2048 in decimal. The program likely interacts with Applesoft via zero-page memory G, $0 F0 or specific memory regions for graphics $2000 and $3 FFF for HGR page 1. The repeated $20 bytes JSR 2020 may be padding or data misinterpreted as code, or they could represent a space character in a text buffer, though this is less likely. 5. Anomalies and possible errors. The MVP instructions G, $848, $872, $8 C9 are not valid. 6,502 opcodes. They may be misinterpretations by the disassembler. These could be data bytes or errors in the listing. The PRK instructions G, $804 and $81 C are numerous and may indicate padding, an initialized memory, or a deliberate halt mechanism. The JSR $2020 sequences are suspicious, as $2020 is in the middle of HGR memory and unlikely to be a subroutine. This suggests a data section or an error in the program. Hypothesized functionality. Based on the analysis, the dragon0 program is likely a machine language routine for an Applesoft Basic game, performing one or more of the following tasks. 1. Sprite rendering. The patterns of $44, $CC and similar bytes strongly suggest bitmap data for a dragon sprite or animation frame. The program may copy this data to the higher ease graphics page $2000 and $3 FFF to display the dragon on the screen. Instructions like stan99, y and tsb/trb support pixel manipulation, typical for rendering or updating sprites. 2. Animation or movement. The BNE branches and PI instructions suggest loops, possibly for animating the dragon G, cycling through frames or moving it across the screen. The SBC and OR instructions could handle position calculations or collision detection. 3. Game logic support. The program may manage a specific game object, the dragon, handling tasks like updating its position, checking for collisions, or drawing it in response to basic calls. Jumps to addresses like $87 F, $90 F, or $631 indicates subroutines for different tasks, possibly initialization, drawing, or state updates. For integration with Applesoft, the routine is likely called from Applesoft Basic with call 2048. It may read parameters from zero-page memory or basic variables via pointers like $F0 and return results to basic. Limitations and assumptions. In complete context, without the full game's Applesoft basic code or additional documentation, I'm inferring functionality based on common Apple II programming practices and the code structure. The name dragon0 suggests a dragon-related function, but it could be a title screen, enemy, or player object. Disassembler issues. The presence of invalid opcodes MVP and questionable instructions JSR $2020 suggests either data sections misidentified as code or errors in the program/listing. This complicates precise analysis. Graphics mode. I assume the game uses higher ease graphics HGR as this was standard for Apple II games in 1982. If it uses lower ease or text mode, the data patterns would have different interpretations. No external references. The query doesn't specify how dragon0 is invoked or what memory it interacts with, so I assume standard Applesoft integration E.G, bloat and call. What dragon0 does. The dragon0 program is a machine language routine for an Apple II game, likely responsible for rendering and or animating a dragon sprite on the higher ease graphics screen. It contains bitmap data, byte patterns like $44, 44, 44 and $CCCCCC represent pixel data for the dragon's appearance. Graphics manipulation, instructions like stat-tsp and trp copy or modify pixel data to display the dragon. Control flow, loops bitmap, and jumps JNP JSR handle animation or movement, possibly cycling through sprite frames or updating the dragon's position. Integration with Basic. The routine is called from Applesoft Basic via call 2048 to perform tasks too slow for Basic, such as real-time graphics updates. The program's small size 1 kilobyte and structure suggests it's a specialized routine, possibly one of several on the diskette, handling a single game element, the dragon, within a larger game framework. Answer. The dragon0 program is a machine language routine for your 1982 Applesoft Basic game on the Apple II, running on a Motorola 6502 processor. It likely renders and animates a dragon sprite on the high-resolution graphics screen. The code includes bitmap data E.G, $44 $CC patterns for the dragon's appearance and instructions to manipulate pixels, loop through animation frames, or update the sprite's position. It's designed to be called from your Applesoft Basic program E.G via call 2048 to handle performance-critical graphics tasks, enhancing your game's visual or interactive elements.